Good morning, Year 12. On page 93, we have got the definition for molecular formula, if you copy it in from the picture. And then if we look at the first question. So we're told that the empirical formula of the compound is CH2O. Remember, the empirical formula is the simplest ratio. Okay. Now, we're also told in the question that the molecular mass is 180. Now remember, the molecular mass is worked out from the molecular formula. Now, as you've copied in at the top of the page, the molecular formula is the actual number of atoms. It's not the simplest number of atoms. Now, if we use the two, then we can determine the molecular formula of the compound. Now, what we've got to do first is we've got to use the empirical formula to work out the empirical formula mass. And I'm just going to use EMF for the empirical formula mass. Now, the atomic mass of carbon is 12. The atomic mass of hydrogen is 1, but we've got 2 of them. And the atomic mass of oxygen is 16. Now, when we add that together, we'll find then that the empirical formula mass for this compound adds up to 30. Now, if we try to link the empirical formula mass to the molecular formula mass, the MR, we'll see that if we take that empirical formula mass, which is 30, and multiply it by 6, we actually get the molecular formula mass, which is 180. So the molecular formula mass is 6 times the empirical formula mass. So therefore, the molecular formula is going to have to be 6 times the empirical formula. So the molecular formula, the actual number of atoms in the compound, is 6 times the empirical formula. So it's C6H12O6. And remember, the empirical formula can be got from the molecular formula by dividing across by a certain number to get the simplest ratio.